Hello again and welcome back to our course on Excel 2013 Advanced. In the previous section we looked at regression, specifically linear regression. In this section we're going to finish off looking at this with consideration of a very important function, the linest or linest function in Excel 2013, that can not only enable us to predict using linear regression but can also give us a pretty good measure of how good any predictions we make are likely to be. Now, using the linest function is a tiny bit tricky. Once you're used to it, it's absolutely fine. But understanding the results of using the function is a little bit more of a challenge. If you don't have a particular interest in statistics or your statistical knowledge is not that strong, some of the results of this may be a little bit complicated. You may have to do a little bit of research to find out what they mean. However, in this section I'm going to look at the meaning of the main ones, and the ones that are most likely to help you I think you'll find relatively straightforward to understand. Now, first of all, what we have to do is to select a range on the sheet with the data that we're using, which is of the appropriate size. It doesn't matter if it's too big, but it's best if it's the right size. And for linear regression using the linest function in Excel 2013, you basically first of all need to count how many independent variables are involved and add 1, because that's the number of columns you're going to need. Now, in our particular example, we only have one independent variable, x, the quarter number, so add 1 to that, we need 2 columns. Now, in terms of the number of rows we need in the area to select, if all you want to do is to get the slope and intercept, you just need 1 row with those 2 columns and you'll get the slope and intercept. But if you want the various statistics that you can use to identify both how strong the model is and what sort of allowance to make for errors, as I'll explain in a little while, you need an additional 4 rows. So if we're going to make maximum use of linest, in this example we need 2 columns and 5 rows. So let me select a range here, 5 rows and 2 columns, and then I type in equals linest, open brackets. First of all, the known y's. There we have the known y's, then the known x's. No surprises here. There we have the known x's. Then we have 2 constants. Now, for the first of the constants, we are again looking at whether we have an intercept or not. If we have the value here set at false, then the assumption is that the relationship is of the form y equals mx, as it says there. No intercept, which is not the case. We need true here because we know there is an intercept. And then for the final argument, whether we want the additional regression statistics or not. So do we want all the additional statistics out of linest as well? We do. By default that's true, but let's specify true. And then to enter the function, again, because it's an array function, it's Control, Shift and Enter. And what we get is a nice big bunch of numbers in the middle there. Now the top 2 are the gradient and intercept of the line. They're exactly the same numbers as we had before. But the other bunch of numbers here give us information about the relationship between y and x that Excel has established. Now let's take a quick look at the linest function in Excel Help. If we look at that page in Excel Help, it explains quite a bit about what the linest function is and how it works. It explains the arguments and so on. But some way down there it shows a picture that includes a close-up of what in our case is the 10 cells that came back as a result of using the function. Now, apart from the top 2, which would actually be the gradient and intercept of the predicted line, there are 8 other items in there, and each of those is explained at various points in this documentation. So for instance, the bottom 2, SS reg and SS res ID, the regression sum of squares and the residual sum of squares. I'll talk about sum of squares in just a moment. But the 3rd row, the left hand item there, the thing that's actually labelled here as R2, is actually a very important number, even if you're not very strong on statistics, because it's called the coefficient of determination. And basically this determines how strong the relationship is between y and x. Now, in most cases it's that coefficient of determination that is the most important of the statistics that we get back when we use LINEST, and the value that we have here is 0.89. The value you get will always be between -1 and +1, and a value which is near -1 or +1 indicates a strong linear relationship between the independent and dependent variables. If you actually came out with a coefficient of determination nearer to 0, that would indicate a weak relationship. Now, one important point to make here is that we're only trying out a linear relationship. The relationship between y and x could actually be something else altogether, and sometimes in practice you may need to try a number of different types of relationship to find the one that is strongest. In our case we have a value there of 0.894, let's say that's approximately 0.9, which is actually quite a strong relationship. So if we were proposing that the relationship between sales and time, in this case quarters, was a linear relationship, this would indicate quite a strong likelihood that that could be true. And just to emphasize the strength of the argument or the possibility that this is a linear relationship, I've once again drawn that little line there, included the chart showing the relationship for the known x's and y's, and you can see that it does have a strong sort of linear shape to it. If we had a relationship, x's and y's, which were exactly linear, then going up from left to right we would get a coefficient of determination of +1. If the relationship was going down from left to right we would have a coefficient of determination of -1. Now, if you don't have that more extensive statistical knowledge and you don't particularly want to get into it, then just using the LINEST function like this and looking at the coefficient of determination to check how strong the likelihood of a linear relationship is actually perfectly adequate for most purposes. I did say just now that I just mentioned this sum of squares business. The way that Excel calculates the line to fit the existing data is that it works out which line, which straight line, say through this slightly wiggly line, would give a minimum value to the total of the squares of the deviations from it. So if you drew a sort of hypothetical straight line through this lot, and then for each of these data points you worked out how far it is from that line, squared that, and added all of those squares together, which line makes the sum of those squares the smallest? And that's basically how linear regression in this instance is calculated. That's how Excel does this job, and it's pretty much the standard way of doing linear regression based on the sum of squares. Now, as I said much earlier on in the course, I'm trying not to wander into areas where detailed statistical knowledge is needed, but for those of you with an interest in or knowledge of statistics, the Excel help page on LINEST function is very helpful, and it explains in great detail all of the statistics that come out of using LINEST, and actually later on you'll find quite a few examples, including some involving multiple linear regression with many variables. It's a very useful page to go through if you want to find out more about regression and LINEST. For those of you who just want to be able to use it in a very straightforward way, I think I've just described how to do that. And just one other thing to point out here, when you're using array functions, which we've done a couple of times now, when you click anywhere within the array where the values that are coming out of the use of that function appear, notice that the equals LINEST is in each of those cells as the formula. So the LINEST function is used in the formula, but you have curly braces around the whole thing. Whenever you see curly braces around a formula like that, it should say to you that what we're dealing with here is an array function in Excel 2013. That's it for this section. I'll see you in the next one.